Hello, everyone. I think I'll start class right now. So today I'm going to be talking about chemical equations. So this is basically chemistry, how chemists describe real world things using chemical symbols so we can understand how reactions occur. So that's what chemical equations are about. First, I want to discuss about the homework for last week. You guys did pretty well this time. You got an average of 5.17 out of 6 on week 3 homework, so that's pretty solid. For this week, there's going to be 8 questions in a Google for this homework, and it's going to be on Google Classroom as always. I think it's going to cover 2 questions about elements and like 4 questions about periodic tables and 2 questions about molar mass. So that's the breakdown of what the homework will cover, and we'll cover all of that in class today. And if you have any questions or suggestions to improve this course, please contact me at the email below. I'll be posting these slides at the end of class today on Google Classroom. So the first thing we're going to do is review chemical formulas. We briefly covered them last class, but this class we're going to go more in depth in them. And we're also going to be doing molar mass today. So that might require a calculator, or if you're good enough, mental math. This lesson would definitely be a lot more mathy than the previous lessons. And then we're going to understand what a chemical equation is and how to do them. And then in the end, we'll tackle some chemistry Olympiad problems. These problems are pretty challenging, so we're going to cover 2 of them today. So, but first we're going to talk about chemical formulas and molar mass. So remember last time I talked about a chemical formula. It's basically using representation that uses atomic symbols with numerical subscripts to convey the relative proportion of different elements in a compound. So, and subscripts, like as you can see in H2O, 2 would be considered a subscript. So that's a subscript. And atomic symbols, remember, they're a 1 or 2 letter abbreviation of elements on the periodic table. So like H, that's a atomic symbol for hydrogen atom. O is the atomic symbol for oxygen atom. And remember that atomic symbol is 1 or 2 letter abbreviation. If it has 2 letters, well, it's easy to be, we can easily see because the first one would be uppercase and the second one would be lowercase. Like NA, the first one's uppercase and the second one's lowercase. If the second letter is lowercase, then we know it belongs to the first, and this is only one atomic symbol. However, if we have 2 uppercase letters in a row, like NF3, then N and F are 2 distinct elements. It's not 1 element, it's 2 distinct elements. So that's how you can tell. If it's a 2-letter atomic symbol, the second one would always be lowercase. Otherwise, they're all going to be capital. And in H2O, this 2 means for every molecule of water, there's going to be 2 hydrogen atoms, and there's going to be 1 oxygen atom. If there's no subscript, it's implied to be a 1. So that's what it means. So here's another example, NaF. So as you can see, NaF, the first 2, we know this Na is an element atomic symbol because the A is lowercase, so it belongs to the first one. And then a second element is F since it's capital. So it has 2 elements, Na and F. So for CO2, it's similar. So the first one's capital, so C is its own element, which is for carbon. And the second one, which is O, that's another element, and it's oxygen. And that 2 means for every carbon atom, we have 2 oxygens. So we have 1 carbon and 2 oxygen for CO2. And CO2 is the natural gas that we exhale due to cellular respiration, and it's essential for photosynthesis in plants. So that's a cool tip about CO2. So now we're gonna do some example problems. Please type in your answers in the chat. It's okay to get them wrong, but at least try. So AU, so how many different elements are in the following compounds? Yep, I see a lot of you have the right answer. Everyone actually had the right answer. It's 1. So remember, the second one is lowercase, so it belongs to the first one. So it's just one element. And AU is gold. So that's a fun fact. How about this one, H2? Please type your answer in the chat. I see a lot of people have the right answer. And it is 1 again. So the only atom left is hydrogen. This 2, remember, it means in one molecule of H2, there's going to be 2 hydrogen atoms, but there's only one distinct type of element. So that's why it's 1 still. How about NABR? Ooh, that one's kind of trickier. How many different elements are in NABR? Okay, I see a lot of correct answers. Yep, you guys all got it right. So Na is the first one since it's lowercase, so we know it's 2 letters. And the second one is Br, which is bromine. So Na is commonly found in table salt, and bromine is a common gas when it's in a form. So there's two different elements there. How about SiO4? Okay, you guys are getting this? That's correct again. The correct answer is 2. Si, which is silicon, it's a common semiconductor used in electronics. And O, oxygen. So there's 2 there, 2 different elements. How about H3PO4? How many different elements are in that compound? I see there's a little confusion with this one, so I'll go over that one. So the first element is H. The second one is also capital, so that one's also a different compound. And the third one is capital, and that one is also. So there's actually 3. An easy way to count how many different elements is to see how many capital letters, because each capital letter has each element has only one capital letter. So that's an easy shortcut to see how many different elements there are. So we did pretty good. So let me erase everything. Okay. So now we're going to talk about how many distinct types of atoms there are. So For example, if I give you the compound, let's say F2, we know that there's 2 atoms of F. So that's how I want you to type in the answer. If I give you the compound F2, I want you to like say 2 atoms of F. And if I give you a compound like CCl4, the first thing to see is how many different compounds there are. This is one compound and Cl is one compound. So there's 1 atom of C and 4 atoms of Cl. So that's basically how I want you to answer the questions. So the first one, they're basically the same compound, Au. How many atoms of each element are there in one molecule? You can either use the chemical abbreviation I presented, or you can either type in its real actual name if you know it. Okay, I see quite a few people got it right. Remember to type in the symbol and not like just one, because we don't know. Well, for this one, there's only 1 atom, so that's fine. But in the future, since there might be different elements, I want to see different. And the correct answer is 1 atom Au, or gold, if you guys knew that it was gold. How about H2? Try that one. So how many atoms of each element are there? Okay, I see a lot of people with the correct answer. Oh, and here's a tip. When you make abbreviations, like for H, make sure to make the H capital H and not lowercase h, because the atomic symbols are always capital. They're never lowercase. So yes, the correct answer is 2 atoms of hydrogen, or H. How about this one? NABR. So this one actually has different elements, more than 1 element, so you need to talk about both. So yeah, for this one, you need to specify the atom names. And yep, everyone's getting it correct. So the first thing to do is see how many different atom elements there are. There's an Na, so we have 1, since it has no subscript, so 1 atom Na. And then it has also a Br, so 1 atom Br. So that's the correct answer. How about SiO4? So I'm doing this exercise so you guys could see how to interpret a molecular formula to see the different atom makeup. So that's the point of this exercise, so we can learn more. Yep. Okay, I'll just say it out loud since this one might take too long to write. So there's one atom Si, which is silicon, and 4 atoms oxygen, which all of you got right. So how about this one, H3PO4? So how many atoms of each element are there? Good. So you can just say 3H1P4O. I can understand that. I feel like that's a really good shortcut way of saying it. But you can also type out in words if you want to as well. And some of you are fancy and you already know what the elements stand for, so that's pretty good. H is for hydrogen, P is for phosphorus, and O is for oxygen. So that's good if you knew it. And the last one's going to be a bit of a challenge. Fe2SO4, and that thing in the parentheses 3. So this is kind of weird notation. It's different from the other ones. But in a parentheses, that's basically saying you have 3 molecules of SO4 together. So whenever you have a parentheses, this means you have 3 of SO4s. So that's basically a good hint to help you solve this problem. That's what a parentheses 3 means. It means everything inside that parentheses has 3. Okay, you guys are all getting it. So basically the answer is there's 2 atoms of Fe, there's 3 atoms of S, which is sulfur, and there's 12 atoms of O. As you can see, there's 4 plus 4 plus 4, which is 12, and the 3 S's add up to 3. So that one was kind of tricky, I do have to say. So now we're gonna move on. So I'm gonna explain a concept called moles. Right now, it might be a little counterintuitive why chemists need such a thing, but I'll try to explain why we need it. So when chemists work in a lab or at an industry, they're usually working with a lot of molecules. So for example, if we have a 10-gram sample of ethanol, where a gram is like a paper clip, so we're basically having 10 paper clips mass worth of ethanol, we have around 1.31 times 10 to the 23rd molecules of ethanol, and that's a huge number. And it's kind of hard to do many calculations when we're working with something with that many numbers. So basically we want to make a mole equal to a large number. So instead of dealing with times 10 to the 23rd, we could just deal with like 1 or 2. And 1 and 2 is more easy to understand and easier to write down. So that's basically why I'm gonna introduce something called moles, so we can reduce the number of molecules. So chemists defined moles to be the number of molecules in a 12-gram sample of carbon-12. So that's basically just an arbitrary, you're arbitrarily assigning a number to be a mole. So 1 mole of ethanol has the same number of molecules as the carbon atoms in the 12 gram of carbon-12. So a mole of anything has the same number of molecules. So a mole is actually this number right here. It's going to be 6.0221367 times 10 to the 23rd. That's actually the number of carbon atoms in a 12 gram sample of carbon-12. So we're going to define this to be 1 mole. And mole is sometimes abbreviated as MOL. So this term mole has another name called Avogadro's number. So that's a useful, they like to ask this in like academic team competitions or science bowl sometimes. Avogadro numbers is equal to 1 mole, which is equal to the number of carbon atoms in a 12 gram sample of carbon-12. So a mole is basically just an arbitrary assigning that we're going to use later on. So 1 mole of any substance is so we're going to abbreviate it to 6.02 times 10 to the 23rd molecules of that substance. So 1 mole of gold is 6.02 times 10 to the 23 gold atoms. 1 mole of silver is 6.02 times 10 to the 23 silver atoms. So 1 mole of math textbooks would be like 6.02 times 10 to the 23rd math textbooks. So a mole is basically just a number, just like how a dozen eggs is like 12 eggs. A dozen pencils is 12 pencils. That's the same thing with a mole. So now I'm going to talk about molar mass, which is a key important thing converting moles to grams. So in the laboratory, chemists use a scale to measure how much each chemical is. And we need a conversion between how much it weighs and the number of moles, because moles are needed in chemical equations, and molar and grams are basically how we measure it in lab. So the molar mass of a substance is the sum of the atomic masses of all of the atoms in a molecule. So basically, if we have a molecule CO2, the molar mass of this compound is the sum of the mass of a carbon atom, 1 carbon atom, and 2 oxygen atoms. This is a 2. So this is the molar mass. The molar mass is the sum of these distinct elements. So we're going to do a few calculations with them on the next slide. So we're going to talk about H2O, which is water. So like the example we just did from calculating how many atoms in each molecule of H2O, there's going to be 2 hydrogen atoms and 1 oxygen atom. So to calculate the molar mass, we have to sum up all of these. Remember, we can find the atomic mass on a periodic table. It's the number below the element. So in this case, hydrogen is 1. So it contributes 2 times 1 AMU. So it says 1.008, but you can literally just round it to 1 because it's close. And oxygen is so close to 16, you could round it to 16. So it's 1 times 16. So when I ask in the next slide to get the answer, you can either just write the sum. You could either write 2 times 1 plus 1 times 16 if you don't have a calculator, or you can just simplify and do mental math, and it's 18 AMU. So that's basically the molar mass. We're just finding the sum of each individual atom. And we look in a periodic table to find the sum of each atom. So, and then we report the molar mass is 18. So that's how it works. So we're going to do an example problem with CO2, which is a lovely carbon dioxide. And here are the periodic atomic masses for the elements. So please type in your answer in the chat when you solve this problem. So the molar mass of CO2. Some people are really good with mental math. And yeah, you don't have to be exact. You can round. What I would do for carbon, just round this to be 12 and oxygen to be 16. Like, we don't really need to keep that many decimal places. Okay, just in case if you don't understand this process, I'll start from the very beginning. The first thing you want to do is see how many different elements there are. So C is capital, so that's an element, and O is capital, that's an element. So that's basically the first thing we did, is to find how many different elements. And the second thing we did today was to see the relative proportions. So there's one carbon atom, and then there's going to be 2 oxygen atoms. And now we use a periodic table. We saw that carbon is 12, so 1 times 12 plus, and then oxygen is 2 times 16. So you can just type this in. This is a 12, sorry. Oh. So you can just type 1 times 12 plus 2 times 16, or you can do it in your head and get a total of 44 AMU, which is the correct answer. So if you don't understand this, please ask a question in the chat, but we're just tying together everything we've done so far. We first identified the elements, then we identified the relative proportions, and then we multiplied them by their mass found on the periodic table. So 12 plus 16 times 2 is 44 AMU. So let's do the same thing for this element, CHCl3. And here's the atomic masses for each of them. Let's just say this is 12. Carbon is 12. Hydrogen we could just assume to be 1. And chlorine we could assume 35.5. How about 45? 35.45. Just kick out the last 2 digits. So please type it into the chat when you are done. Remember, it's the same process as last time. You don't have to be exact. If it's close enough, then it's fine. I see some correct answers. Someone raised their hand. Sophie, do you have a question?
Can you tell me, I can't really see what you're writing because, it's annotation. I can't really see clearly. So, can you tell me what's the value for chlorine?
35.45, sorry.
Okay.
Just knock around everything to 2 decimal places, but if they're close to a whole number, just take the whole number.
Okay, thanks. Okay, I got something weird, okay? Just maybe.
Ooh. Some of our answers are all over the place. So I'll just do this problem and we'll all. So the first step is to see how many different elements. Carbon is an element, hydrogen is an element, and chlorine is an element. So we need to determine how many of each type there are. So since the coefficient, there's no subscript in the carbon, there's 1 carbon atom. There's no subscript for the hydrogen, so there's 1 hydrogen atom. And then there's a subscript of 3 for chlorine, which I think is the major issue that most people are making. We have 3 chlorine atoms. So it's 1 times 12, because the mass is 12 here. 1 times 1 for the hydrogen, since the mass is 1 there. And then the last one is 3 times 35.45. So this is 12, this is 1, and let me do the last one on my calculator. This is 106.35. So the correct answer is anywhere in the ballpark of 119.35. If you say anything from 115 to like 120, that's pretty close enough. So that's how we solve the molar mass. We first see how many distinct elements, then we'd see how many types of each element, and then we just multiply it based on the periodic table. And I see a lot of you got the right answer, which is really good. So this is our last one. It's a really challenging one because this is the confusing one from earlier. Find the molar mass of Fe2 at open parentheses SO4 close parentheses 3. So one of my first tips is to see how many types of each atom there are, because this one might be a little harder to do by just eyeballing it. So I would first determine how many elements there are, then how many types of each atom there are, and then just multiply it by the weight. Remember, you don't have to necessarily give me the answer. You can just show me the intermediate steps in the chat as well, and that's perfectly fine. I'll let you do your own rounding on this problem, and I'll just accept within a range. You guys might round differently, but that's perfectly fine. I'll give you some more time since this one takes. Ooh, we're all over the place here. So remember, when I talk about molar mass, I'm talking about the sum of each mass. So let's work through it together. First, we have to determine how many different elements there are. So Fe is the element. The second element is S. And the third element is O. Remember, this notation of 3 in front of the parentheses means all of these, there's 3 of everything inside. So there's going to be 3 sulfurs. There's going to be 3 molecules of SO4, and each molecule of SO4 has 4 oxygens. So there's going to be a total of 12 oxygens, and then 2 E atoms. So that's how you're going to do it. And then all you have to do from here is you multiply against the according molar mass. You do 2 times 55.84, 12 times 16, plus 3 times 32. And then you add that all up. And you get 399.9, which is anywhere from like 390 to 400 is pretty good. And a lot of you guys got it right. So great job, everyone. If you got it right. This one was kind of a harder question. So we're going to have 2 questions like this on our homework, finding the molar mass. But instead of giving you out these elements, I'm just not going to give the elements out on the quiz and just give a periodic table. So later on, when there's a periodic table, I'll tell you how it looks like, but you're going to have to do a scavenger hunt to hunt for each individual element. So like Fe, you're going to have to hunt for where Fe is and then find the mass. And then like S, you're going to have to find where S is on the periodic table. But everything's on the periodic table, and you can get every single element and all the masses on the periodic table. So now we understood the elements. We're now going to understand what chemical equations are. So a chemical equation is a symbolic representation of a reaction in terms of a chemical formula. So the things we had like CO2, CHCl3, SO2, that's a chemical formula that represents a molecule. So basically we're having a reaction with those types of things. So for example, I'm going to talk about adding lithium metal into water, which has this equation. Remember, lithium in the alkali metals are extremely reactive in water, and they would just burn in water. And here's a picture of it burning in water. So this is a chemical equation. The thing down here, this is what a chemical equation does. It has an arrow, and it has some things on the left of the arrow and some things on the right of the arrow, and it has these numbers in front of each thing. And we'll discuss it more each part later on. And normally they're not color-coded, but I color-coded them to make them easier for you to understand as we discuss them. So the first thing we're going to discuss about them is the reactants. So the reactants are the things that react. So they're going to be on the left side. So I color-coded everything in red as the reactants. So Li is a reactant, which is the lithium metal that we drop in water. And water, H2O, is also a reactant. So an easy way to remember is reactants react. So they're on the left side. So those are our starting materials, or what we use together to react. Now an arrow. So arrow just basically means they react to form or yield. So we're reacting two things, and it's going to form the products to the right of the arrow. So the green things to the right of the arrow are the products, and the arrow means they react to form these products. The reactants form these products. And then products are the substances that are formed. So LiOH, lithium hydroxide, and H2, which is the hydrogen gas. Those are the things that are formed in this reaction. So H2 is the thing that causes the explosions. It's because H2 is not compatible with oxygen, so it will usually provide a violent spark, as you saw in the picture before. So that's basically why it makes those sparks, because hydrogen gas is forming and they burn in air. So the last thing I want to talk about is coefficients. So coefficients are the numbers in front of a reactant or product. So basically the numbers in blue. So as you can see in H2, it doesn't have a coefficient. When a substance doesn't have a coefficient, it's implied to be a coefficient of 1. So coefficient tells how many molecules is in a reaction that they react with. So we have 2 molecules of lithium reacting with 2 molecules of water, and we form 2 molecules of LiOH and 1 molecule of O2. So it just gives the relative proportion that we need. So if we have 4 atoms of Li, then we're going to need 4 atoms of H2, 4 atoms of LiOH, and 2 atoms of H2. So it's basically a proportion. So if I have like in Li, if I have 10 atoms of Li, note that I multiplied everything by 5. So I'll have 10 of H2 because these numbers are proportionate. So also we have to multiply this one by 5. So we'll have 10 of LiOH and then 5 of H2. So that's basically what the coefficients tell us. They tell us the proportion, and that's important. So here's an example problem. Lithium metal explodes in water with the equation 2Li plus 2H2O yields 2LiOH plus H2, which is the equation I just talked about. So if 6 moles of lithium react with 6 moles of water, how many moles of H2 gas are formed? So please type your answer in the chat when you have the answer. Good. I see correct answers. Everyone who's typed something so far has gotten it correct. So if you're good at math, this might come really easy as proportions, but if not, then here's a way you can do it. So you first find Li, and then you want to find H2. So you look at the coefficients. It's a 2-to-1 ratio. So Li to H2 is a 2-to-1. Since we have 6 moles of Li, let X be the moles of H2. Since we know that they're in a constant proportion, 2 over 1 equals 6 over X. So X is 3. So that's another way to solve it. So yes, everyone who got 3 moles is correct. There's indeed 3 moles. So if you're good at math, you might not have to do this proportion stuff, but it's good if you aren't that comfortable with math. So how about LiOH? Given the same starting, how many moles of LiOH would there be? So we're still having 6 moles of Li reacting with 6 moles of H2O. Good. Everyone who's answered gotten it correct so far. I see some people are confused with what I mean. So instead of H2 here, replace H2 with LiOH. So if 6 moles of Li react with 6 moles of water, how many moles of LiOH are formed? So just answer that question, replacing H2 with LiOH. Okay, so look at the proportion. There's 2 Li to 2 LiOH, so it's in a 1-to-1 ratio. So if there's 6 moles of Li, there's going to be 6 moles of LiOH. So that's basically what it means. So let's rephrase it. If 5 moles of H2 are formed, so instead, in the last problem, we talked about reactants, but now if we're given 5 moles of product, how many moles of Li is needed to react? So this is basically the reverse. Remember, everything can be solved with this equation right here. Basically, the numbers basically give us a ratio, and that's what I want to stress about. So the ratio of H2 to Li, you can see there's a 1 for H2 since it doesn't have a coefficient, and Li, it has a 2, so it's in a 1:2 ratio. Since we know we have 5 here, so we're going to multiply everything by 5. So we're going to have to multiply lithium by 5. So 2 times 5 is 10. So the correct answer you should give me is 10 moles. So good job to everyone who got it. So in this one, how about H2O? So basically replace H2O in terms of Li. So answer that same question for H2O. Good. I see a lot of correct answers. Okay, so basically you look at the coefficients again, H2O and H2. It's a 1:2 ratio. So if we have 5 moles of H2, we're going to have 10 moles of H2O, which all of you got correct. So that's really good. So one more. So instead of, so we could talk about 2 of them being both on the product side. So if we have 5 moles of H2, how many moles of LiOH are there? Since we're kind of running out of time, it's the same thing. It's a 1:2 ratio. As you can see, it's a 1:2. So if we have 5 moles of H2, it's going to be 10 moles of LiOH as well. So there's 10 moles of Li, 10 moles of H2O, and 10 moles of LiOH. So let's do the same thing for another example. So the equation H2 plus 3H2 yields 2NH3 is a general process to synthesize ammonia, which is an important compound in cleaning solutions like bleach and pesticides. So what are the reactants of this reaction? So we're going to tie everything together. So what are the reactants? You don't have to give me the coefficients, just tell me the however many reactants there are. Please don't tell me the number of reactants, but tell me what exactly the reactants are. If you forgot what reactants are, reactants react to form the product. So when I'm asking for the reactants, I'm not asking for the number of atoms in each reactant. I'm just talking about, so basically you see N2, that's a reactant. And then you see H2, that's a reactant. Anything before this arrow is a reactant. So N2 and H2 are both reactants. It's not N and H because N and H are different atoms than N2 and H2. because these are distinct compounds called N2 and H2. And H2 is not the same as H. Although H2 is made out of hydrogen atoms, this shows that the hydrogen atoms are bonded together, and in the lone state, these are not. So just like copy down these exact atoms without the coefficients. So that's how you answer that type of question. So what are the product of this reaction? So remember, products are the things that you form at the end. So basically the products, you just look at NH3. So just type in NH3. That's the answer. It's not NH. The subscripts are important because NH is not a stable compound, but NH3 is. So just be aware you have to type in the full compound. Yep. And that's how you do it. So let's practice some more mole stuff. So if 2 moles of NH3 are formed, how many moles of NO2 react? I'll clear everything so it's easier. So if 2 moles of NH3 are formed, how many moles do we need to react with N2? This is the exact same thing we did on the previous slide where we did proportions. Okay. So yeah, I'm seeing the correct answers in the chat. So to answer this question, we want to see the proportion between the two elements, NH3 and N2, and we use the leading coefficients to compare them. There's no coefficient here, so we give it a 1. There's a 2 to here, so it's in a 1-to-2 ratio. Since we know we have 2 moles of NH2, we have 1 mole of N2. So that's how we do the problem. Yep. How about the next one? So how many moles of H2 react? So this means instead of N2, H2. Remember, this is just all proportions. So instead, it's 2 to 3 this time. And since we know there's 2 moles formed, it's easy, it's just 3 moles here. Okay, and then the last one we have for today. If 3 moles of N2 react, how many moles of H2 are needed to react? So if you get this one down, I think we should be pretty good. I realize some people are enjoying math more. It's a ratio. Look at the coefficients of N2, which is a 1, and H2, which is a 3. So we know 3 moles react and X. So we keep a constant proportion. So X equals 9 to keep the 1-to-3 ratio, which is the right answer I've seen. Okay, so I'm going to briefly go over the chemistry Olympiad problems. So I want to reiterate what I talked about last time about atomic radii. As you go down a group, remember that a group is like one column, vertical column. The atomic radii increases. The reason is that in each period of the table, like this is one period, this is the second period. Each period, it has an extra shell of electrons. So this is hydrogen atom, which is right here. It's the smallest because it only has one shell. This is lithium atom right here, and that's this element. You see it has two shells, so it's going to be bigger. This one is going to be sodium. It has 3 shells, and you can see the size is much bigger. Potassium has 4 shells, and it's going to be a lot bigger. So that's why as you increase, you get a higher number of electrons since there's more shells. However, as you go across the row, the atomic radii actually decreases. I see that I have a question. Yes.
Why are some pink and why are some yellow and why are some gray and others, green or blue or brown?
It says at the bottom that the data uses colors derived from these plastic. So I think it's just
Can't see.
A company decided to use these colors, and I guess that's why. I don't really know.
So it's arbitrary?
Yeah, it's arbitrary. Okay. So now I'm going to talk about as you go across each row. As you can see, the atom size decreases in each row. So this is the lithium atom, which is right here. It's the biggest one, and then beryllium is right here, and it decreases. So rationale is that it has the same number of shells, but there's more protons in a beryllium than a lithium atom. There's 4 protons. So, and because positive charges attract each other, it pulls in the electrons tighter. So that's why it decreases. So as you go down, the atomic radii increases, but if you go from left to right on a periodic table, the size actually decreases. So this is the first chemistry Olympiad problem. This was the periodic table I was talking about earlier. You're gonna have to do like a scavenger hunt to find which types of elements there are. So the question is up here on the top. As the atomic number increases from 11 to 15, the atomic radii of the elements A increase, B decrease, C increase then decrease, or D decrease then increase. So please type in your answer in the chat when you think you got the right answer. It's okay to get the wrong answer. At least just try. So the first thing you have to know to solve this problem is what is the atomic number? So remember, the atomic number is the number of protons, and it's in the top of the periodic table. So the atomic number 11 is right here, 12, 13, 14, 15. So those are the elements, as you can see. And as we just learned, as we go across the period, the atomic radii decreases due to more protons, but the electrons stay in the same shell. So the correct answer is B. So let's do our last problem of the day. This one's pretty challenging. Which element has chemical properties most similar to P? So you're gonna have to do like a scavenger hunt. Since we're kind of running out of time. Remember the properties about what I taught about last week, how properties, the same properties are in the same groups? Like all of these metals explode in contact with water. That's the same thing for which one has the similar chemical properties. So you're gonna have to see which one's in the same column. And yeah, it is pretty hard since there's actually 2 elements in the same column. So here's phosphorus. The A answer choice is nitrogen. The B answer choice is aluminum. The C answer choice is sulfur. And the D answer choice is arsenic. So how can we differentiate between A or D? Well, we know it's not aluminum. We know it's not sulfur since it's not in the same property. But a general rule is that these group 2 elements do not share as much similar properties with the rest of the elements in its group because it's much smaller in size. So actually the right answer would be D. That's an example of a tricky problem that you have in an Olympiad competition. You have to know that the period 2 are just so small that they don't share as much similar properties because AS has much more similar properties than in phosphorus. No, nitrogen is not correct out of question. It's arsenic because I said period 2 groups are too small and they don't share as much properties with the rest of their group. So it's actually AS, arsenic. So today we talked about chemical formulas and molar mass and to see how many atoms there are. We understood a chemical equation and balancing, and then we did 2 challenging chemistry Olympiad problems today. So this week there's going to be 8 questions in the Google form for the homework this week. And I believe there's 4 equations, 2 molar masses, and 2 how many elements are there. So if you have any questions or suggestions, please contact me at this email. The homework should be posted by now. If not, it'll be posted pretty soon. And that's it for today. Thank you guys for listening.